so just laugh, even if it's not funny. Just laugh. Anyways, so here we have a sale for a toy boat, right? There's two right triangles, no surprise there. He has cut out the raw material for triangle ABC. So ABC is this triangle right here. And angle B is 72 degrees. It's already labeled. It won't always be labeled, so be okay with that. He knows that side AD, so this side must be 9 centimeters long. And that the base of the finished sail must be 7.8 centimeters long. That's already labeled, right? But don't get too used to this part, right? I provided a diagram. Soon we're going to have to make our own. The question is, at what angle must he cut DAC? Angle DAC. Where is that located? Angle DAC, if you could right now go into your diagram, where would that be? DAC, right? And then go back and forth between the 3 points you've created, and then you realize this is the angle that the question is asking us for. Okay. So I will call this, I will have a heading for this one, right? Oblique triangle meets right triangle. Okay. So sometimes, like actually quite often, you're going to have both. You're going to have right triangles and oblique triangles. Oblique is the big one, both at the same time. And I'm going to ask you to sometimes ignore the right triangles. Almost imagine like Control Z. You know what Control Z does on a computer in Word? Undo, undo, right? I want you to get to the point where you get rid of this and just think of the big triangle, the oblique triangle. Okay? So how am I going to approach this? I don't know if you see it, but I see a pair. I see that this angle goes with that side. Okay, so you've got a pair. So that is, in my opinion, that's going to be my starting point. Okay, so I'm going to go sine of 72 degrees over the side across from it, which is 9 centimeters. And what is the only other thing I can do? What is the other piece of information that I'm given? The base, right? Is this base going to give me this angle? And I would say no, because this angle is attached to this stretch right here, right? You get that point? 7.8 goes from end to end. So what angle am I going to get from that one? All of A, yeah. I'm going to get the whole thing from here all the way to there. Okay, but that's okay. That's going to help us get closer to our goal. So I'm going to go sine of angle A over 7.8. So that what I'm trying to get you to see is please don't mix triangles up. We're right now working with the oblique triangle. So if you were to say, oh, I'm solving for that side, now you're mixing up an angle that is part of our right triangle with an angle that should be part of the whole big triangle. So don't mix them up, okay? So here we go. Now we're going to solve for A. Sine of A, right? You cross multiply and then you divide. This is just for you. This is not showing your work. This part is showing your work. I'm going to divide this by 9. And I'm going to try to fit in that 0 point something there. You should start with a 0, this part that's, when you're trying to find an angle, it has to start with a 0, or else you're going to get a math error on that one. Sine of 72 divided by 9. There we go. It starts with a 0, 0.82, and I'm just going to go dot, 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 indicating that I'm using all decimals. And then my last line, this is okay to show this step, to just go angle A, and then you just make sine inverse appear on the other side. if you want to keep doing what you were doing yesterday, and when I looked at your whiteboard work, you did the inverse to both sides. That's actually, I don't know if better, but that's just fine. Yes?
I had the same question.
Okay, so it doesn't matter.
Yeah.
They're both mathematically correct. So let's take the inverse. So I'm just going to go second sine, copy, paste. Should I close the bracket, Mr. Erickson? If you're just having that number, there's nothing multiplying it, it's okay to not close the bracket. It's up to you. 55.51 degrees. But that's not the answer yet. This is important, but it is not my final answer. Maybe I'll try highlighting. See if this works for you. I don't know if it's going to work for you. But this angle right here goes from end to end, right? It's the whole thing. So now you have another pair, by the way. You've got the 7.8 and the angle across from it, but we're going to stick to this pair for solving purposes. Okay? So now how else I'm going to approach this? If this is a 90, this is a 90 also. Okay, that's guaranteed. There's a straight angle there. So what I'm going to do is I'm going to use the fact that the 7.2 is here. I know the 90. I'll find out what this is, and then I'll subtract that angle from my previous answer, and I'm left with that little wedge there. Okay, that's my approach here. So angle, what are we calling that? BAC, right? Angle BAC is 180 minus 90 minus 72. So that would be 90, 18, right? 18 degrees. And I'm going to use a color for that as well. So this angle right here is this piece right there. And now I'm ready to answer, okay? I'm going to call angle DAC, which is what they're asking for. Angle DAC is equal to 55.51 minus 18. So yes, this one had a lot of moving parts. Could it be done in a different way? I will say absolutely. If you were able to do this using a different route, I'm very okay with that. Okay. So this is your final answer. Please always indicate or label your final answer clearly. Okay. So this was step number 1. Okay, step 1. Then I use this one as my second step, right? And this is step 3. But we're not done yet. There's a B part to this. Let's see, I'm going to try to make that fit here. If you look at the bottom, determine the length of the mast AC. So they want, what do we call this? The something of a triangle? The height of the triangle, right? Okay, what's the shortcut again? Height is going to be equal to the slant times sine of angle. Angle adjacent. Okay. I would like the whole everything to be on there, so sorry if it's a bit small here. Do we have a slant? We have this slant, correct? 9. Do we know this angle? We don't. Can we find it? We've got enough info, right? We can go 180 minus this, minus that. So remember, I'm dealing with a big triangle here. So I'm going to subtract that and then get angle D. That is the adjacent angle, and then I'm going to multiply it by 9. Okay? Yeah.
You can also use the angle A there, right?
This one?
Yeah.
No, you can't. You can't use the angle between the slants.
No, like the whole angle together.
Yes, yeah, I'm going to use the whole thing.
Okay.
To get this one, I'm going to go 180 minus this whole thing, and then get that, yes. Alternatively, you could have gone 180 minus just this 37 minus 90, right? You'd still get the same answer. So it's up to you how you want to use it, yeah. So let's see here. Angle D is 180 minus 72 minus 55.51. That is 52.49. Okay. I'm going to zoom in now to that one. So now I'm going to use the 9 multiplied by sine of this. And if you're wondering what's going on here, this here is 52.49. And this is 9 centimeters. Okay. So now I have the slant. To find the height here, I have the slant, I have the angle between the slant and the base. So it's going to be 9 times sine of 52.49, which is 7.14 centimeters. This is what we kind of touched on yesterday. I always like to give you an or. Or. How else could you have done this? I'm going to pick this triangle because I have the 9 here. I know that this is 52.49 at this point. Okay. So I want to know the height. So if you don't like the formula that I just gave you, if that confuses you, cut out your triangle where the height is visible, and then just do your pair thing. This is a pair, correct? So we can go sine of 90 over 9 is equal to sine of 52.49 over h. Okay? And I can guarantee you I'm going to go dot, dot, dot. H is also 714. I actually have that worked out. Could it be, right? Could it be that this is easier for you to visualize, to actually just, like, you know what, Mr. Erickson, your formula is kind of confusing me. I'm just going to do one of these and see my pairs, pair them up, use sine law. Absolutely, you go for it. You don't have to use the shortcut. But sometimes the shortcut is just a little faster, right? It saves you all of this work. Yeah.
In this case, it's a right angle, right? I mean, a right triangle.
Yeah.
Can you use SOHCAHTOA for this?
Yeah.
Can, right?
You could use SOHCAHTOA for this, yeah. Just be careful to make sure it's not a right triangle.
Yeah.
So I don't even talk about SOHCAHTOA because sine law, cosine law solves any triangles, any of our problems. We don't need SOHCAHTOA. When I introduce SOHCAHTOA, students they mix it up all the time, and now we have a bit of a mess to clean up, right? So I would say let's do sine law, cosine law only right now, and maybe at the end I might say, hey, remember SOHCAHTOA? It still works, right? It's okay. So that's why I don't talk about. Those are primary trig ratios. This is sine law, cosine law. Yeah. All right.